Good day, grade 10s. This is Sarah van Gillen, aka Mr. VG. And I cannot believe that we are on the last video of grade 10 trigonometry. Exam practice part 2. In this specific exam practice video, we are going to have a look at solving some interesting questions. Specifically 3 or 4 questions that I love to ask in this exam. So let's start with the first question. The first question is question 1. Write down 2 possible ratios for cos of angle A. Stop the bus. Before we get too far with a sum like this, we always draw my triangles apart from one another. And now I specifically want to look at the 90-degree, the right angle triangles. So I'm going to look at drawing them separate from one another. The first one, okay, there we go. I've drawn them apart. You'll see I've got 3 90-degree triangles. One is triangle ABD, triangle BDC, and triangle ABC. Why do I draw them like that? They are like that on this sketch. And I'm going to look at all 3 because all 3 has a 90-degree triangle in them. Let's look at your basics. I'm looking for cos of A. Therefore, I'm not going to look in triangle BDC because there's no angle A. My next step would be labeling the sides. So if I start at triangle ABD, from angle A as my vantage point, AD is adjacent, BD is opposite, and AB is the hypotenuse, the longest side, or opposite the 90 degrees. I'm going to repeat this process with triangle ABC, again looking from angle A. The hypotenuse is where I love to start because it's opposite the 90 degrees. AB is now the adjacent and BC is the opposite. Always go back to SOHCAHTOA, our favorite. SOHCAHTOA. I'm specifically going to look at cos, the adjacent over the hypotenuse. In triangle ADB, the adjacent is AD, while your hypotenuse is AB. Whereas if I look in triangle ABC, the adjacent is now AB, and the hypotenuse is AC. Awesome, amazing, and very, very interesting. It seems like I've got 2 completely different ratios for the same trigonometric function. Not difficult if you have drawn your triangles apart. So that's always my step 1 with composite triangles. Let's look at the next question. You go and try this one on your own first. The angle of depression of a yacht on the ocean from the top of a lighthouse is 11,3 degrees. So angle of depression. So in other words, from the horizon to the hypotenuse, 11,3 degrees. If the height of the lighthouse is 55 meters, calculate the distance between the top of the lighthouse and the yacht along the line of sight, the length of AC. Whoa. Too much information, too many words. Why don't we first just draw a sketch showing exactly what they told me, but just without all the fancy stuff. First of all, what does that 11,3 mean for my triangle? Well, there's also 11,3 there. But why? But why? Well, it's because it's the horizon. And DC is parallel to AB. Okay? That is a very simple thing that you have to put into your sketch. So I have that bottom angle A, 11,3 degrees. What am I looking for? I'm looking for a side. I'm looking for AC. So I'm going to write out my 3 basic steps for calculating a missing side. Let's start by labeling the sides. There's adjacent, opposite, and hypotenuse because I'm looking from angle A. What am I looking for? SOHCAHTOA shows me that working with opposite and hypotenuse, I want sine of 11,3 degrees because those are the sides that I'm working with, the opposite and the hypotenuse. I've chosen my function. Now I need to solve it. I'm going to solve it first of all by multiplying both sides by AC, which leaves me with AC sine of 11,3 equal to 55. AC is not on its own yet. So I am going to divide both sides by the 11,3. On the left, they divide away, leaving me with an answer for AC of 280,69 degrees. Interesting little question. Does it make sense? How do I know? Do you remember I asked you this question previously as well? How does it make sense? Well, remember, opposite the 11,3, I've got 55. The 90 is much bigger than the 11,3. So the side opposite the 90 must be bigger than 55, significantly bigger. So does the 280,69 make sense? Yes, it does. Simple and as easy as that, grade 10s. Let's move on to the next question. A small little question. Determine the value of cosec x equal to 2. What makes it different from the previous work? We haven't done reciprocals inside trig equations. And I warned you, I'm going to throw this one at you. Hit the pause button and try it yourself. If I look at the calculator doesn't have cosec on it, but it does have sine. Because cosec, remember, is the reciprocal of sin x. So in the place of cosec x, I can put 1 over sin x, because that I can try and handle somehow. So I'm going to write this equation, rewrite it as 1 over sin x equal to 2. Now you see that I've done an over 1 there. Why did I do an over 1? Here's the reason why. I am doing a sneaky little trick on you. A dirty old school trick, which is reciprocating both sides. For us laymen, reciprocating basically means flipping both sides. You can do that as long as there's an equal in the middle. If there's a smaller than or bigger than, whoa, that can't work. But let's quickly reciprocate. So sin x or sin x over 1, if you want to put the 1 there, it doesn't matter, it doesn't really make a difference. But now I'm sitting with sin x equal to 1/2. Do you know how to do this? I hope so. Let's unwrap the gift. Sine to the -1, or arc sine of 1/2. which leads me to x being 30 degrees. So in a nutshell, grade 10s, if you are sitting ever with a reciprocal identity, remember to introduce your normal sin, cos and tan, because those your calculator can work with. Let's look at the last one, the last question in this topic. When I look at this, oh my goodness, this is a Mr. VG special. John tries to solve the equation sine of theta equal to 5 over 3. When he tries to solve it using his calculator, he gets a math error as a result. You can go and try it yourself. Put arc sine of 5 over 3. See what's the answer. You get a math error. Now why is that? Well, I'm guiding you into that. Draw a labeled right-angled triangle to illustrate and explain why there is no solution. Try it yourself. Use SOHCAHTOA. Use the knowledge you've got. Draw that right angle quickly. Let me work with you. If I look at sine of theta being 5 over 3, according to SOHCAHTOA, that is opposite over hypotenuse. So in a right angle triangle, yours could have been flipped around, it doesn't matter, but the opposite would be 5 and the hypotenuse would be 3. Is there a few alarm bells that's beginning to ring in your mind? Well, in my mind there is. In my mind there's a few bells that's starting to ring here, because if I look at this, the opposite side is longer than the hypotenuse. But the hypotenuse must be the longest side. So does it make sense? No! The hypotenuse must be longer. Therefore, there is no possible solution for this equation. Now, interesting enough, this kind of leads us towards the following. That sin of theta must lie between -1 and 1. Now please, ignore the negative ones for grade 10. So let's rather make it a bit simpler for grade 10. Let's say for grade 10, sine of theta is going to lie between 0 and 1. Please understand, next year it's going to go towards the negatives, but that's grade 11 work. The same with cos of theta. It's always going to lie between 0 and 1. Because remember, sin of theta is opposite over hypotenuse. Your hypotenuse has to be the longest side. While cos of theta, remember, is adjacent over hypotenuse. So your hypotenuse again must be the longest side. So it has to be smaller than 1. Your fraction has to be smaller than 1. This is some very interesting mathematics. And I love these kind of questions because they kind of bring together your understanding of SOHCAHTOA with angles, with length of sides. Man, I love mathematics. Everything comes together. Grade 10s, have a beautiful rest of your day. Remember to practice the work in the worksheet and have a beautiful, amazingly wonderful rest of your day. Keep well. Cheers.